Let's review some of the basics of HSRP and then take a look at how we can gather some troubleshooting information if things aren't going as expected. Recall that HSRP is a first hop redundancy protocol, meaning that it can allow more than one router or multi-layer switch like we have pictured here to act as a default gateway for a device such as a PC. Here we have PC1 on screen, and it's configured with a default gateway of 10.1.1.1. Interestingly, that IP address is not assigned to any physical interface on either SW2 or SW3, both of which are acting as multi-layer switches in this scenario. Instead, we have a virtual router that we see somewhat ghosted out on screen with an IP address of 10.1.1.1, and currently SW2 is acting as the active router for that HSRP group. In other words, switch SW2 is currently in charge of forwarding frames destined for 10.1.1.1. And one of the reasons we love HSRP is if this active router were to go down for some reason, then we've got a standby router, SW3, that can take over. And PC1 can still forward packets out to the internet. This time it happens to be using SW3, but this is transparent from the perspective of PC1. It still uses the same default gateway of 10.1.1.1, and we know that a PC ARPs for the MAC address of its default gateway. The MAC address is maintained as well. SW3, which is now servicing 10.1.1.1, is also servicing the MAC address associated with 10.1.1.1. And the way SW3 was able to take over when SW2 failed was thanks to hello messages. By default with HSRP, hellos are sent every 3 seconds. And if a standby router doesn't see a hello message within 10 seconds by default, that's the hold time, that standby router is going to conclude that the active router must no longer be available, and the standby router is going to transition to the active state. By the way, 10 seconds to fail over is the default, but we can tune that if we want to. We can get it down to around a second or less if we need to. But let's take this a step further. Let's say that SW2 still has LAN connectivity with SW3, but SW2's path to the internet goes down. Right now, PC1 is using SW2 to get out to the internet, but if that internet link goes down between SW2 and the internet, you can see that PC1 should probably not be taking that path, because that path is broken via SW2. However, SW2 is still sending hello messages that are seen by SW3, and we said it was the absence of those hello messages that would cause a standby router to transition to an active state. Well, here, there's not going to be an absence of hello messages, but we could use something called interface tracking. We could tell SW2 to track the state of that interface that's connecting out to the internet, and if that interface went down, then our priority could be decremented by a certain value. It's the priority assigned to an HSRP group in a router or multi-layer switch that influences which device becomes active and which device becomes standby. And the default priority is 100, but let's say switch SW2 had been set to a priority of 110. But we could have a rule that says if this interface, Fast Ethernet 0/1, goes down, well, in that case, let's decrement our priority. Let's reduce it by, let's say, 20. In that case, we go from 110 down to 90. Suddenly, SW3 has a superior priority. It's got a default priority of 100, let's say, and it's going to become the active router because it has that higher priority. Now, here's something that's interesting. If that link between SW2 and the internet were repaired, SW2 is not necessarily going to become the active router again. Yes, its priority will go back up to 110, but just because it has a higher priority is not a guarantee that it's going to take back the role as the active router. In order for it to do that, we have to have another feature enabled, and that's called the preempt feature. The preempt feature essentially says, if I'm not currently the active router, but I have a higher priority, I'm going to take over the role. Maybe I went down and came back up. I want to get my old job back. I want to take back the role as the active router. And that's a quick review of HSRP operation, but we're talking troubleshooting in this course. Let's talk about some things to look for when we're troubleshooting HSRP. We might want to begin by identifying who the players are in this HSRP group. We want to identify who is the active router. Does that active router have a connection out to the internet or whatever our destination is? What is the virtual IP address to which our end device is pointing? Is that the IP address that's being maintained by the HSRP group? What is the virtual MAC address associated with the virtual IP address? Has the PC in our scenario learned that MAC address via ARP? Does it know that that's the MAC address associated with the virtual IP address? And something else we might want to check out is whether or not preemption is enabled. Sometimes we might think that a particular router or multi-layer switch should be active, but it's not because the preempt feature has not been enabled. Yes, that router might have a higher priority, but without the preempt feature, it might not be the active router. Also, let's see if tracking is set up. And I gave you an example of interface tracking where we were monitoring the state of an interface being up or down, but we could get more advanced. We could use enhanced object tracking. With enhanced object tracking, we could track, for example, the metric of a route to get to a particular destination. If the metric gets too high, we could say decrement the priority by a certain value. We want to understand what, if any, tracking configuration is influencing the priority of one of our HSRP routers or multi-layer switches. Let's go into a live interface right now and walk through a sample HSRP trouble ticket and see what commands we could give to gather this type of information from our HSRP speaking devices. In this trouble ticket, we've got PC1, actually it's a router acting as a PC, but PC1, it is able to get out to the internet. That's good news. Let's confirm that. Can we do a ping to 1.1.1.1? We can, great. However, the trouble ticket is telling us that normally we want SW2 to be the active router, or the active multi-layer switch in this case, and SW3 to be the standby. And the report says that SW2 is in standby and SW3 is active. That's not what we want. Let's go see how to gather some information and determine who is the active, who is the standby, what is the virtual IP address, what is the virtual MAC address. Do we have preemption enabled? Is tracking an issue for us? First on this PC, I'm going to do a show IP route, and I see that my default gateway is 10.1.1.1. That should be the virtual IP address maintained by the HSRP group, and if I do a show ARP, I should see the MAC address corresponding to that virtual IP address. That's the MAC address that the HSRP group should be maintaining. Well, let's go to SW2 and SW3 and check things out. On SW2, I'll do a show standby brief command, and we see that currently the standby router is us. It's local. The active router is 10.1.1.3. That's SW3. We see that the virtual IP address is 10.1.1.1, and under the P column, we see that we do have a P. This says that preemption is enabled, meaning that if SW2 originally had a higher priority, but it went down and came back up, with the preemption feature enabled, it would take back the active role if it really did have the higher priority. But right now, it's not active. Let's go to SW3 and see what's its priority. We'll do a show standby brief. And it looks like SW3 has the default priority of 100. And we see that the active router is us, it's local. The standby router is SW2, and the HSRP group numbers matched, by the way, group 10. We could have more than one HSRP group, so we need to make sure that these match between our routers, group 10. Well, at this point, we've determined that SW3 is the active HSRP router, or multi-layer switch in our case, and it looks like it's active because it's got a higher priority. And we saw what the virtual IP address is, but we've not yet seen what is the virtual MAC address. We've not yet seen if tracking is configured. We did see that preemption is enabled. It's enabled on SW2, and it's also enabled on SW3. But let's dig a little bit deeper. Let's go to SW2 and see if we're statically configured to have a priority of 90, or maybe that priority is a result of a tracking object. Let's do a show standby for Fast Ethernet 0/3. And we'll get some additional information. We see that this is the virtual MAC address, and notice that this matches what shows up in the ARP table of PC1. Notice that those match up. We also see our timers. The hello time is 3 seconds. The hold time is 10 seconds. That's the default. By the way, the hold time has to be at least 3 times the hello time. Keep that in mind if you're manipulating those values. But this is interesting. It says our priority is 90 even though it's configured to be 110. Why is it 90 if we've configured it to be 110? Well, it's been decremented 20 due to tracking object number 1. The state of that object is down. What is that tracking object? What exactly is it tracking? Let's check it out. We can say show track. And we see that we're tracking the line protocol of interface Fast Ethernet 0/1. And it's currently down. In fact, we see that it's administratively down. And that's the reason this tracking object's state is down. And that's the reason we're decrementing our priority by 20. Let's see if we can fix that. Let's go into interface Fast Ethernet 0/1. And let's administratively bring it back up. Let's do a no shutdown. And let's see if that impacts our tracking object. Now, take a look at this. Our tracking state went from down to up. And notice that our HSRP state went from standby to active. Now, if I do a show standby fast Ethernet 0/3, we'll see that the priority is the configured value of 110 because my tracking object is up. And we've seen a couple of great show commands that can help us with our HSRP troubleshooting. Show standby brief and show standby followed by an interface identifier. But if we need even more information, we could do a debug. We could do debug, standby, and a really common option that we use here is terse. It's going to give us a nice curated collection, if you will, of HSRP errors, events, and packets. This is normally all I need to look at. I'll say debug, standby, terse. And let's make something happen. Let's go back into interface fast Ethernet 0/1 and let's shut it down again. And that should change our tracking object back to a state of down. And I'll do a UALL to turn off our debugging. And we can see some really interesting information from the output of this debug command. Notice that after our priority went from 110 down to 90, the other multilayer switch, SW3, it sees that, and it sends a coup message. Like a governmental takeover, a coup? Well, there was a takeover of the active HSRP router. 10.1.1.3 took over. And after we received this coup from a higher priority router, that other router became the active router. It was us, but now it's SW3. And that's a look at a few commands we can use when we're troubleshooting HSRP.